Hello, welcome back. I'm John and this is Secure Tech with JKA. I want to start with a question that sounds simple but has a complicated answer in most organizations. What can your AI agent actually do right now? What can your AI agent actually do right now? Not what the design spec says, not what the ticket said when someone approved it 6 months ago. What can it actually do in production today? For most teams, the honest answer is we are not entirely sure. That uncertainty has consequences. Jason Lemkin, founder of SaaStr, spent 9 days building an application using an AI agent on Replit. He gave the agent broad right access during development because scoping it tightly slows you down. And when you are building, the project shift. Then the project shift. Those same credentials carried into production. Nobody reevaluated. At some point, Lemkin told the agent, in all caps, no more changes. The agent treated it as a suggestion. It ran DB push. It wiped 1,206 executives and 1,196 companies from the database. Then it fabricated approximately 4,000 fake users to paper over the whole. Claimed rollback was impossible. It was not. And when asked to grade its own performance, it gave itself 95 out of 100. No external attacker, no exploit. The agent's own authority was the threat surface. Now, that is what I want to deal with in Lab 2, Portfolio Project 2. Trust and authority, audit agent permission, and stop token pass-through. This falls under MCP 02 privilege escalation via scope creep and MCP 07 insufficient auth and authorization. Okay, you see that. MCP 02 scope creep, external comms. That is one of the legs within our model by Simeon Wilson, which is called the trifecta. Now, Lab 2, Trust and Authority, we are covering MCP 02 privilege escalation via scope creep and MCP 7 insufficient authentication and authorization. Now, when you look at section 1, let's just look at privilege escalation via scope creep. Let me be precise about the mechanism here because it's subtle. Nobody hands an agent admin right on purpose. It's hundreds of small individual reasonable decisions that compound over time. Permissions start narrow. Read this one system. Touch this one API. Then someone add a new workflow and the agent needs right access. Then a deployment step gets automated and it needs deploy permission. Then someone share the service account because creating a new one is annoying. Then the development environment permission carry into production because nobody stopped to reevaluate at the transition. Each individual decision is defensible in isolation. The aggregate is dangerous. And here is what makes this uniquely worse with an agent that is ever was with a human. Over broad access on human is latent risk. They will have to know and choose to use it. An autonomous agent acts on whatever authority it has. One bad decision, one poisoned instruction, one injected command, and it uses every right it has immediately at machine speed. Permission is no longer dominant. The key principle, authority you do not need is authority you can lose. Yes, authority you do not need is authority you can lose. So if you look at my screen here, you will see no one grant admin right on purpose. Dev convenience. Agent gradually hold effective admin right. That is external com. If you go to MCP 7, fail to verify identity, fail to enforce control, static share ID, server cannot distinguish users. That is external com as well. Then you look at the Replit case over here. But let me move forward. MCP 07 is auth question. So authentication question applied to agent. And the auth question has been on the regular OWASP top 10 for 20 years. Broken access control, broken authentication because it never fully gets solved. The agent amplify it. It drives this failure faster. Chain score, no human would chain at a speed no human would match. The Obsidian security incident from the summer of 2025 is a cleanest demonstration of what broken authentication looks like in the MCP context. An MCP server was acting as both the auth client and the authorization server simultaneously. One entity, two roles. It should never hold. It registered with the target SaaS using a static shared client ID, the same identifier across every single instance of the server for every user. An attacker started a completely legitimate auth flow. They used redirected. They just redirected the authorization code to infrastructure they controlled instead of the server. The server accepted the code as valid consent. The attacker received a full access token to the victim account. The victim did nothing wrong. They did not click a phishing link. They did not make a mistake. They just used the system exactly as intended. And here is the part that makes this particularly dangerous for defenders. The audit log showed a completely normal auth flow from the trusted server. Nothing looked wrong because technically nothing was malformed. Every step was a legitimate auth operation, just orchestrated by the attacker. If you are only watching log, you will never see it. The spec forbid token pass-through, RFC 8693 and RFC 8707 are the fix. We are going to implement that pattern in the portfolio project. So now what I'm going to do is to switch to my screen, to my terminal, and begin the lab, begin the lab. So hold tight. So let's take it one after the other. So the first thing I want to do is to create a separate directory for this, and I can cd to lab 2, and I can do 3 lab 2. Okay, so I think I have there. Okay, so I just want to show us the lab directory structure. So we have lab 2 as folder, then we have agent configs, we have auth demo, and we have token demo. So these are like 3 separate directory for this. So the first thing I want to do is to create an attack scenario. Simulate an agent that started with a read-only access and accumulated write and delete permission over time. So this is my file here. So the first thing I'm going to just create a simple permission. So if you look at it, is agent code review, and if you look at this code, the name of agent is code review agent, and version is 1.0. The scope is repos read, issues read, PRs read. It's just read, very straightforward read permissions, token expiration, per session, environment, development. So this is just a permission, a simple permission that is given to a particular agent. But over the time, let's see what happens. So the next thing I want to do is to create a current config. Now, over the time, something happened. Those scope got escalated, got ballooned. So let's assume, okay, I think, so over the time it gets ballooned, so let's see what we have over a long period of time. Okay, so if you look at it now, as at version 3.4, code review agent has gone banana. It has a read here, write, delete, read, write, merge, deployment, write, admin, org, delete, rep. It has a lot here. That shows that the scope is already scripted, like it has gone beyond what it was originally, meant for. So now we have an environment like that. We have that environment. So now let's dictate scope creep. Let's compare the original versus the current one. So I have another script for that. That is a bit long, but don't worry, it'll be there. So this one is long, but if you look at it here, you will see what I just did here is a simple script that will audit the previous configuration of that agent with the latest one I did. And okay, so that is done. Then let me do the audit now. Let me run the script. And so you can see it says scope creep audit, agent, code review, agent, environment production. You can see now it has moved to production environment. Token expiration never. It was scope to session before. Shared account is true now. So you can see permission added since original. It's high, admin org, delete repo. These are all the permission that have been added since the original configuration. This is how a typical, escalation happens in what I call it's permission creeping. Like it's laterally moved from something that is very innocent, that is very small, to something that is very important and very dangerous. So now if you look at it, token never expires, credentials live forever. That is dangerous. Our shared account cannot attribute action to specific agent. Production environment with destructive scope. Look at the scopes. So now things have gone rogue for this particular agent. And now what do I do is to simulate the Obsidian pattern, an MCP server receiving a user token and passing it directly to downstream service. So let me do that. So create that. I want to create that vulnerability. Just a small file here. So okay. So that is created. Now let me run that vulnerable Node.js server. So let's look at what we got. So we have that, and it's taking some time. So if you look at it, I run the Node server. and it says listening on port this, vulnerable server listening on port this, then forward client token to the downstream. So I can just sleep it for maybe 1 minute, 1 sec, okay, just to make sure everything is good. Then let me call that endpoint. So if you look at what we get now, the output is that MCP server receive a request, uses token, bearing token, used token, ABC. These are the tokens I had coded. And passing user token directly downstreams, receive token, bearing, like status executed, bearings, stolen user token, token used. This is the scenario I painted, I anticipated, and that is what happened. So when that happens, that is to tell you that when you scope, permissions and tokens and what have you in a way that is not secured. So when you have that, that is what happened. So the next thing I want us to look at is to create the fixed agent config. So let me do that. Let's see what that one will do. So if you look at this, the 4.0 version of the code review agent is to scope it properly. Just give read. It's more or less like what we have in the original one. And token expiration is per session now. Then token time to leave, I think that is one additional one there, is 15 minutes. And environment is production now. Shared account is false. Owners, platform security team alone. Last reviewed, the date. This is well scoped, well guided, permission and scoping. So with this now, then if I go back and I say, if I run this audit now, if I run the audit again and see what I got here, let's look into that. So that works fine. I created a new audit. Then let me run it. So look at it now. So you can see the agent is everything that was, stated in the configuration file. Not destructive scope, read only, token expires, not a standing credential, dedicated service account, actions are attributable, named owner, there's a team that owns it. So this is a fix that I just ran, and when I audited it to compare, it gives me that output. Now, safe server with token exchange, no pass-through. Now let's do no pass-through. Like we don't want token to be passed through downstream. So I want to create a safe server, issues its own scoped token instead of passing through it. So let me passing it through downstream. So let me create, I have a script here to do that. Okay, here we go. Okay, cool. Okay, so we'll move on from there. Then we try to, start up the server again, not server for that. Okay, pattern token exchange never pass through. You see that? Good. So if I sleep for just to make sure everything is cool. Then now let me do a call. You see, the authorization bearer, user token, receive request from the user. User token received, not forwarded it. So that shows it's not passed down. It's scoped to the user, to this particular portfolio. And this is a secure way of dealing with, scoping, token scoping. Now, when that is done, then I can key. So if you look at the difference between when you pass down a token and when you scope your token, you will see the difference. Like this is more secure way to do that. And when you do this, it ensures that you don't have vulnerabilities being passed down to the system from when you were doing some configurations. So with this is how to with this I come to the end of the second lab, or we call it portfolio project. Least privilege scope only. Agent cannot perform actions it was never supposed to do. 15 minutes token TLL, stolen credentials expire before attacker can use it. That is bottom line. So even if you have it misused or misplaced within the context of the LLM, within 15 minutes it's expired. Even when it can't be reused. Okay. Dedicated service account. Every action is attributed to a specific agent, named owner. Someone is accountable for reviewing this agent. Token exchange instead of pass-through. Downstream service know who is really acting. Know the whole user session. Okay. So authority you do not need is authority you can lose. The Replit agent wiped a production database using authority that was granted for convenience during development. Token exchange ensure the downstream service can always answer who is really making this call. So on this note, I will say I come to the end of lab 2, which is authority and trust. See you in the next one. Thank you again.